Hello again. So here we meet again, and I will work in this recording on chapter 4. So from page 26 to page 45 in the booklet. So we'll cover some basic types in C, operators, and expressions. So for me, this is the most difficult chapter in this course. So I advise you to be mentally and physically present and to focus on each notion and do not hesitate to pause sometimes and then rerun some of the parts of this recording, and do not forget to hit the red subscribe button of this channel and then hit the bell icon to turn on notifications. And again, if you have any questions, do not hesitate to send it to me by email in order to answer you back, either by writing or by making a new video. So we have seen the last time this code. So here I'm more giving clues about what we are seeing. So besides the commands, for example, here we have variables. The variables are manipulated by the program. It means that they will be used by the program. The values of these programs will be of these variables will be changed during the course of the program. So each variable here, it has a type. For example, here we say it's int. It means integer. It means that the number could not have a comma so they are a real integer natural numbers. So we have here control operations. So it's like a test. We are checking whether the counter here is less than 4. We have here expressions and instructions. We are modifying the values of the variables that we declared earlier at the top of the program. So today we will talk about the types, the different types of variables like int, float, double, long double. We will see how we can construct an instruction and what's the difference between an instruction and expressions. So first, the most important remark that I can say is about the flexibility of the C language. It had a lot of types and a lot of operands. So if you are using a lot of operands in the same calculation and you have different types, you will end up with an answer or a value of a type that is not predictable. So you need to take into account and to avoid to have some problems while you are having a calculation. So you should be aware of how the C language operates, how it makes the calculation, what we mean about the automatic type conversion, what about the rounding, the casting. So if you study well this chapter, you will have a strong foundation on how you can overcome all this problems later while solving much bigger problems. So in math, we have a various set of numbers. We have the natural number n, the relative number z, the rational skew, and the set of real r. In fact, in mathematics, we can have number that goes from minus infinite to plus infinite. However, in our life in computers, we have a limited memory, and thus we cannot have an infinite number. So they should have a limit size. So as we know, the computer uses the binary system to do all the operations. So what about large number? So he should have another representation. So first, let's talk about simple types. So as a programmer, a user should be aware that he can choose a numerical type that appropriate to a given problem. For example, if he wants to do the sum or the average of numbers, an average could be a real number, so we should be aware that the answer could be a real, even if the grades or the numbers are integers. So he also need to choose a suitable type for the representation on the screen. For example, if he doing an average and there's 100 numbers after the comma, he will not display the 100 numbers on the comma. He should be aware that he needs to choose something reasonable to display on the screen. As we have said earlier, he should predict the resulting type of the operation, especially when there's a lot of numeric types. For example, if he is doing summation between an integer number and a real number, so he should be aware that the solution, that the answer, it will be an real number, not an integer number. He should be aware that he can also force the calculation by doing some casting. We will talk about this part later at the end of this chapter. So, as for the PC, every number he stores it in this form. So usually there's one number behind the comma. There's a sign for the mantissa. We call this one the mantissa. It's usually 6 numbers in the representation of the C. We have here the base, and again we have the exponent and the sign. So this is the scientific notation, and the PC uses it to store any float or real number. So let's take an example to see what can go wrong when doing some calculations in C. For example, if we have this operation and we are doing the summation between the first two terms, since they are in a bracket, so the PC, since it uses only 6 decimal places, so if he converts 850 to 10 to the power 8, he will probably loses the 850. So this one will be equal to 0, 0, 0, 0, 0, and 0 multiple 10 to the power 8. So because the 850 cannot be expressed in 10 to the power 8, so at the end he will have the same number as the first term, and then he subtracts the second term, he will end with 1000, which is a wrong answer. So however, if we swapped these two values, so we try to subtract the first two terms, we will end with 1000 and then we'll add 850, so we will add up with a correct answer. So the purpose or the idea from this is that whenever you are making an operation in C, you should be aware of the types of each number. So if you have a big number and you want to add it with a small number, it's not the same thing as in mathematics. So as we go on with the course, you will learn more techniques about how to overcome these problems. It was just an example to give you an idea that what we learn in mathematics, it's not that we found in real life in computer science. So when we define a type, for example, in integer types, we should look at two characteristics. First, what can be expressed in this type. So it's the range of allowable values and the number of bytes that is reserved for the variable. So for the integer type, we have 5 types in the integer types. We have the char type short, we have the int and long, and we have the long. So for the char, in the system uses just 1 byte. It means 8 bits, and when we say 8 bits, it means that we have 2 power 8 possibilities. It means 256 possibilities. Since we are subdividing the range of 256 possibilities between the signed number and unsigned number, so the minimum value is 100 minus 128 and the maximum value is 127. The short type needs 2 bytes, so it has 2 power 16 possibilities. The int and long, they need 4 bytes. You should note that on some machines the integer needs only 2 bytes, so it depends on your machine. However, in the slides and in the booklet, we have opted for the int type to have 4 bytes. So if you look at the internet or check other books and you see that the integer type is 2 bytes, so don't freak out, it's totally normal. It depends on the machine. The long, it's a long integer and it needs 2 power 8 to 8 bytes. So as you can see, if I want, for example, if I want to store the value 100, so 100, it can be stored as a character, it can be stored as a short, as an int or long, or as a long. However, if I want to store 40,000, I cannot store it as a character because 40,000 cannot be stored in a character, nor in short. It could be either stored as int or long, or a long. So the same applies if the number is negative. So these are the range whenever the numbers are integers and are signed. However, we can use a prefix, the word unsigned, and we can have only positive numbers. So again, here we maintain the same number of bytes. So character is 1 byte, short 2 bytes, integer and long 4 bytes. Here we don't have a negative number. So if you see, the minimum value is always 0. And for example, here in the unsigned car, since we have 1 byte, it means we have 2 power 8 bits. So we have 256 possibilities. So the values are between 0 and 255. Again, if I have the number 1432, so it's unsigned, I can store it either as unsigned short, unsigned int, or unsigned long. So let's move on. Let's see some of the remarks. There are remarks regarding the calculation in unsigned. You should know that if, for example, let's go back, I was storing the value 256 in unsigned car, even I cannot have 256 in unsigned car, the calculation is made modulo 2 power n, here 2 power 8. It means that if I want to store 256 in a char, it will be converted to 0 because the calculation is made modulo 2 power the number of bits in the type that we have chosen. So if you want to visualize it, it's like a circle. You know, we have the number here between 0 and 255. So I can store 0, 1, 2, 300, 255, and when I reach 255, I will go back to 0 and continue. 256, it's like that. So it's like a circle. So make sure that whenever you need to store a number, to choose the correct type. So they are telling us that by default, short int or long, they are signed unless we tell the PC that we want to deal with unsigned number. So if I want to deal with unsigned, I need to prefix the type with the word unsigned. So if you want to know the limit, the minimum values and the maximum values of the different types, you need to check the header file limits.h. So the rational type, as we have explained, it's like the mathematical scientific type. So it has a sign, plus or minus. It has a mantissa. Usually it's a positive decimal with a single digit before the comma. If you are talking about in base 2, so it's either 0 or 1. And an exponent is a number, a relative integer. So for rational types, we have 3 types in C. We have either float, double, or long double. For float, we are using 4 bytes, double 8 bytes, and for the long double, 10 bytes. So here we have the significant number of the mantissa. The mantissa is here. So how many digits can we store in the PC? So if we are using the float type, we store just 6 numbers, double 15 numbers, and long double 19 numbers. So here again, we are having the minimum values and the maximum values. So those are the minimum values and the maximum values in the positive range. However, the negative values may vary in the same range. So look at the exponents here. They are very huge numbers. So if, for example, so usually we use the double unless we know that it cannot hold a double. So we use a long double 1. So we will cover these also later on. So we have an exercise here. So just to know if you grasp the idea about the different types of numbers. So they are asking us which numeric types can you use for the following groups of numbers. So we have groups of numbers, and we need to choose the best and the possible types that we can assign to each. So I have at the first row numbers 1, 12, 4, 0, and minus 125. So as you can see, we have a minus 125. So there's no way that we can choose an unsigned type for all these 5 numbers. So there should be sign. So I can choose char, short, int, or long. So if you come back to the slides, so a char can goes from minus 128 to 127. So 125 minus is in the range of char, so this is the best choice. However, I can choose also short, int, long. I can even choose the float, double, and long double. However, the char type is the best one. We have at the second row 1, 12, minus 4, 0, and 250. So again here, I cannot choose any unsigned number since I have minus 4. I have 250. 250, I cannot store it in a char. I can use, so the best one is to use short. I can use also an integer long as the same way I can use float double and long double. For the third one, 1, 12, 4, 0, and 250. So here I can use unsigned numbers since they are all integers and they have 250. So 250, so the best choice would be the char since it will go from 0 to 255. I can also use unsigned short, unsigned int, unsigned long. I can also use short, integer, or long, and however I cannot use a char because char it goes from minus 1 to 8 to 1 to 7, so it doesn't work. I can also use here float double and long double. For the exercise for the fourth row, I have 1, 12, minus 4, 0.5, and 125. So I have the minus 4, so I cannot use any unsigned number. I have a 0.5, 0.5, it's not an integer, thus I cannot use any signed number. I'm obliged to use the real numbers. So the best choice would be float since I don't have a very big numbers. Minus 220, 32,000, 0. So I have a minus, so it's signed. I have 32,000. 32,000, if I go back, I think it can be stored in short. So short, yes. So the maximum number is 32,767. So I can store the number in short, and this is the best choice here. I cannot store it in a char. I can store it in integer and I can store it in long, and the same applies for the float double and long double. For the following, the 6, so I have minus 3, 0, 0, 0, 0, 0, 5.00 and so on. So this one is a real number, so it couldn't be an integer, so I need to pick the best choice. So either float double or long double, since we have like numbers here. If we want to transform this into a scientific notation, the mantissa will be all even the one, all this. So we need a number of mantissa which is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So if I come back, a 16 would be here. So I should choose the long double. I cannot choose float, I cannot choose double unless I will lose some digits if I choose float or double. So for the second, the row 410, 50,002. So here what we have. So they are all positive. We don't have a comma, so basically we can use all of this float numbers. So what's best to choose? So if you can see, it's not signed, so we can choose non-signed type. So a 5,000, it could go in short, so this is the best solution. It could go in int long. It doesn't work here, and it doesn't work in assigned in it goes in signed integer and in long, but it doesn't go in short and in char. So if you have questions here, do not hesitate to send it to me so that I can answer you back. So this is set. Let's continue. We have 410, 50,000 and minus 2. So here we have minus 2, so I cannot choose anymore any signed number. So here we can still choose those ones. I have minus 2, so what will be the best choice? So it could be here, since the integer could hold. Let's come back, I'm not sure. So an integer could hold, yes, a very big number, so the integer is the best choice. The short is not a good choice. So let's continue. 3.14 and 10.15. So there's a comma. I cannot use all of these. I can either choose a float, a double, or long double. Again, if I want to transform this into a scientific notation, I will have a number of digits in the mantissa that's greater than 6. I cannot use float. I can use double, and of course I can use a long double. 2 power 10 to the 7 and 1000001. So we have a scientific notation. So it doesn't mean it's a real number. So it's a big number. They are all unsigned, so I cannot store the first number in all these. I will store it as a long. I cannot store it as a float because it's too small. I can store it as double and long double, and the best choice would be the long signed. The row that follows, 2 power 10 minus 7. So here we have a comma because it's 10 power minus, so there's 0.0, so it should be one of the float numbers. So again, since I have 10 power minus 7, the number of mantissa would exceed 6, so I cannot use a float type. So the best choice would be a double one, and of course a long double, it could also go. So the row that follows, minus 1.05 multiple 10 to 50 and 0.0001. So here again I have a comma, so I cannot choose any of the signed or unsigned type for these two numbers. So I can either choose float double or long double. So again, the mantissa doesn't work here for the float. Let us see if it could work for the double one. So the number of significant digits of the mantissa is 15. So here the number of digits is just a 3. So even a float is very small to hold this number. So the best choice would be double, and of course the long double one. So here we have a comma, we have 6 numbers, and if we transform it to a scientific notation, we will have 9 numbers in the mantissa. So again, the float number, it won't work. We will store it as a double. This is the best choice, and of course we can use a bigger type like long double in this example. So what we have done in this exercise, so for each set of numbers we have chosen the best economical type and also all the possible types that we can declare these variables, these numbers with. So again, if you have any questions, do not hesitate to send it to me and I'll try to answer you back as soon as possible. So how to declare a variable? We have talked about variables, the types of variable, but how to declare a variable. For example, if I have a variable x, I can declare it of type int int of x. So we write the type, and then we put the variable names, comma, if I want to declare multiple variables of the same type, so I can use the comma. For example, here in the examples, I'm declaring three variables, counter x and y of type int. At the second row, I'm declaring two variables, height and width of type float, one variable of type double, which is called atomic mass, and a char key, a key of type char. So a reminder, as we have done in the previous chapters, those variables should comply with the identifier rules. So any variables should start with a symbol or underscore. It should not start with a number. So, and there's a set of admissible symbols which are 0 till 9, capital letters and small letters, and the underscore. So here there's a, there's no dot. So here is how we declare simple variables. So what are the rules about how to choose a variable? So we have seen examples, and let's review what the rules on how to choose the types. So integers, usually we have the choice between all the integer types, including char, decide, and unsigned. And they are telling us that if the number is too big to be whole in a long, so maybe you could choose a rational type. It could be a float double or long double. So the real, we have three rational types, which are the float, double, and the long double. You should be aware of the number of significant digits in the mantissa and the magnitude of the exponent and all dependents of the number. So usually we opt for double, and if we know earlier that the answer will be very huge, we will go for long double. So the character, a character or char is of type integer, and we usually in C we use the ASCII table. So the first semester of the first year, we have covered the ASCII table, and that each character in the ASCII table, it has a number. So this number will be encoded as an integer in C. For strings, we don't have a string type in C. However, later on we will see how we will handle strings in C. So what about booleans? So booleans, they are Boolean variables always have either true or false logical variables. So in C we don't have a Boolean type. So everything that has a zero, a numerical value, it means it's false, and everything other than zero, it means it is true. So usually we declare it as integer, and we use it as a Boolean. So 0 it means false, and everything else it means true. So as an exercise also, they are telling us they are giving us some indication about in variables and the range of these variables, and they are asking us to specify the most economical type. So I have here integer counter, and the admissible numbers are between 0 and 300, so I can easily declare it as int counter because integer can hold these values. Integer xy minus 120 and 100. Here I can declare it as a char, since char is the most economical one. It goes from minus 128 to 127. The measure, it's an integer between minus 10 and 10 to the power 4. I could declare it as int. A real area, the area it goes from 0.5 to 150075. So here there's a comma, it should be real, it should be either float double or long double, so the numbers are not very big, so I can choose a float one. Float area, real area minus 12 and 1500750.5. So here there's a problem here, since if I want to change to scientific notation, the digit in the mantissa are more than 6, so I cannot use float anymore. I need to choose double area 2. Integer and 1, so it's between 0 and 2 power 10. If we calculate this, it will go into integer type. The same applies for this one, so it becomes easy here. And for the integer, the number here doesn't go in, so maybe long and 3. So if you are using, if integer needs also 4 bytes as long, so we can also choose int and 3. For the and4, I have here 1 to 8 power 5, so it doesn't go in long, so we need to choose a bigger type. So if long doesn't go, maybe we can choose a double one. And since here we have a true or false, as we have said, we encode booleans as integers. So this is done for the exercise. So let's talk now about numerical constants. So what we mean by a constant. So if you remember, when we were working with algorithms, for example, and we tried to do summation or to find a maximum or minimum, in somehow we need to initialize a variable to a value. So this initializations, it should be a constant. For example, I say that at the first, the maximum is equal to a, the maximum is equal to 0, the money, the rate is equal to something. So this, the first value that we should initialize a variable with, it's called a constant. So we distinguish, in fact, 3 types of constant, either integer ones, real ones, or character ones. So whenever we talk about integer constant, we have 2 types, either automatic or force. For example, by default, what's automatically, and if I want to force a type, what should I do? So let's start with the automatic one. So usually when a constant, when we assign an integer constant, C usually uses the most economical solution. So first, he will consider it as an integer. So if the number is too big, it will convert it to a long type. If the number also is too big, and if it's unsigned, it will be an unsigned long, and if it cannot hold in an unsigned long, the answer would be unpredictable. So as with the first type, in the first type we force the constant to be of a given type by adding suffixes. For example, if I want a number to be unsigned int or long, I will add the character u. If I want it long, I will add the L, the suffix L. If I want it unsigned long, I will add the unsigned long. So let me repeat. So in C, the integer constants, they have 2 types, either automatic or force. Automatic, so the compiler, the C, will choose the most economical solution. First, it will try int. If it doesn't hold in int, it will try long int. If it doesn't hold in long int, it will try unsigned int. And if it doesn't hold in unsigned long, it will be cumbersome for him. So, as a first type, if you want a number, a constant, to be of a specific integer constant, you can add a suffix either u, l, or ul. So let's take an example. We have here 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, it can hold an integer. So automatically, C will choose the type int. So this one is a bit bigger for int, so he will choose long. In fact, it's int here because it can hold an int if int is encoded over 4 bytes. -2 also is int because the first thing he tries is integer. So 1u here, I have a forced constant. 1u, it means unsigned int. Here also it means unsigned integer, and lu, we don't have something called lu, we have ul, not lu. Lu is at Venice University. So here we have an error. So we cannot use a suffix which is not available in the C language. So this is for the integer constant. However, we can have also octal and hexadecimal integer constants. So they are the same constants that are integers but expressed in octal or hexadecimal base. So if an integer constant starts with a 0, so it means that it's an octal base. If it starts with 0x, it means that it's in hexadecimal. It's expressed in hexadecimal. So here we have a table of conversions. So just pay attention to the fact that an octal constant starts always with 0, and hexadecimal it starts always with 0 and x. So let's make the first row. So I have here the decimal number 100. So if I want to convert it to binary, so as we have done at the first semester, I will repeatedly divide by 2 till I reach the answer. So let's do it. If I divide by 2, I get 50. The remainder is 0, 25. The remainder is 0, 12. The remainder is 1, 6, 0, 0, 3, 0, 3 over 2, 1, remainder 1, 0, and 1, and I'll get 1, 1, 0, 0, 1, 0. This is from binary. If I want to convert the binary into octal, so we know that 3 digits in octal, it will give us 1 digit in octal, so this is 4, 4 and 1, so we'll end up with 144. Since it's a constant in C, we need to add a 0 at the front of the number, so we end up with the number 0144. The same applies for the hexadecimal, so I will pick 4 digits from the binary, and we'll convert it and we'll end up with 64, and I need to add the 0x in front to say that this constant is an integer one expressed in hexadecimal, and the same applies for the rest of the examples. So we have covered the integer constant. Let's move to the real constants and then to the character constants. So in a real constant, so there should be a dot, so we can express it either in two notation, either in decimal notation, it means we have a decimal notation, or using exponential notation. So the first one, there should be a dot. The second one, it should be the exponential, which means in mathematical notation 10 power something. So example, this one, it means minus 1 multiple 10 to the power minus 3. So we can either choose the capital E or the small e. So again here, so by default, C will consider a real constant as double. Without suffix, always they are of type double. We can use the suffixes F or L in order to force the type of the constant. So if I add F as a suffix, it will be a float. If I add L, it will be a long double. So let's move to the character constant. So a character constant is always indicated between a single quotation. So, and again, a character constant are dependent on the machine, and we usually use here the ASCII code. So let's we have covered this ones in the previous chapter. So escape sequences are character constants, and I will not repeat it, so you can check if you have learned it. You can recheck it quickly. So again, here we have an exercise. I will not pass a lot of time on it since we have done a similar exercise. So it's you need to fill the table. So you have numbers expressed in decimal, octal, hexadecimal, or binary, and then you need to convert each of these. So here is, for example, I will do the first row, just first row. So we have the octal number, which is equal to 01770 octal. It means it starts with 0, so the number in octal is 1770. If I want to convert it, the best is to convert it to binary. So in binary it will be equal to 1 1 1 1 1 1 1 0 0 0, and then I can convert it to hexadecimal. It will be 3f8. I need to add 0x in front, and then from binary or from hexadecimal I can transform it into decimal. It will be equal to 1016. It's just a revision of what you have done in the first year, first semester. We have a more interesting exercise, which is to, for each correctly defined constant, you should need to find the types and decimal numerical values. So here we have constants. So if the type is correct, if the constant is correct, just give the type and then give the value. So we have the constant 1 2 3 3 2. So it's an integer constant. So by definition C, it will choose directly the type int, and the value it will be the same 1 2 3 3 2. 23.4, there's a point, so it's a real constant, and automatically C will choose the double type and the value would stay the same, 23.4. 345 LU, as we have said, there is nothing called LU, there's UL, unsigned long, not long unsigned. 34.5 L, it's a long double, since it is a fourth type, and it will be equal to 34.5. Minus 1.0, it's a real constant, so automatically the C will chooses the type double. 0x EBA, so 0x, it starts with 0x, it means that it's an hexadecimal number, and it's an integer expressed in hexadecimal, so it should be an integer. And if we convert EBA, so A is equal to 10, B is equal to 11, and E is equal to 14. So it will be 14 multiple to 5 6 plus 11 multiple 16 plus 10. It will be equal to 3770. 0 1 2 3 L, 0 1 2 3 L. 0, it means octal, integer octal, and L here it means long. So it's a fourth type long and is expressed in octal. So we need to convert 1 2 3 from octal to base 10 to integer. So it's equal to 1 multiple 64 plus 2 multiple 8 plus 3. It will be equal to 83. We have the quotation here backslash n, so it's a character constant, so it's a char, and in ASCII code it's equal to 10. 1.23 UL, UL it means unsigned long, and we cannot apply an unsigned something to a number that contains a dot that's real. So this is wrong. I cannot apply UL to a real number. Minus 1.0 E minus 1. So we have E, the scientific notation, so it should be a double. So the value would be minus 0.1. 0 F E O. 0 FE 0. So 0 it means octal. However, in octal I don't have FE. So this is wrong. Octal, the digits in the octal system are between 0 and 7. 40,000. So 40,000. So the PC will try to apply int. So int, it's possible. So we'll choose int, and the value will be 40,000. 40,000 U. So U it means unsigned int, and the value will remain the same. 70,000 U, again it will be unsigned int, and the value will be 70,000. 1E 1F, so E it means the real constant, F float, so it's float, and 1 multiple 10 to the 1, it gives us 10. The character 0 is a character since it's between double single quotation, and the value depends on the ASCII table. It will be 48. So we don't need to know the ASCII table. So just as for your knowledge, we have here an O without quotation, so it's wrong since it's a character, so it needs to be between a quotation. Quotation backslash 0, so this is a special character, we have talked about it, the null character, and usually it has the value 0 in the ASCII table. We have a 0, so 0 it's an integer, so the value is 0, it's normal. The character big O, so it's a character since between a quotation, and the value in ASCII is equal to 79. 67 E0, we have E here, so E it means double, and the value is 67. Backslash R, so there's an error here since it's a escape character, but it should have a single quotation here. 0 1 0 0 1, so it starts with 0 and it's an integer, so it's an integer constant expressed in octal, so it should be an integer, and we need to convert 1001 from octal to binary to decimal, so it will be equal to 513. 0.0 L, this one is L, so it's a real constant, and L means is a double. We are forcing the double type, so it's equal to a 0, and at the end 0x EUL. So 0x it means hexadecimal, and the constant should be an integer, and plus we have the unsigned long, so E is equal to 14 and the type is unsigned long. So this is done for the exercise of this exercise, and let's move on to the initialization of the different variables. So we have talked about how to declare a variable. We have covered the constant, so let's mix it together and see how we can initialize a variable. So here I'm declaring a variable of type integers called max, and I'm using the constant 1023, which is an integer constant that I'm assigning it to the variable max. The same applies for the second variable, which is called tab. And in tab, the type of the variable tab is a char, and I'm assigning a character constant, which is the backslash t, to the variable tab. So here again, so as an add-on, we can use the attribute constant in front of the declaration of the variable to say that the variable value doesn't change while we are working with the program. So I'm advise you not to use it, just in case you see it, to know that a constant means a variable cannot change its variable. However, by definition, a variable should change, the value of the variable can change as long as we are working with a program. So let's move now to a more interesting part, is about the operators, the standard operators in C, and then we'll move to the particular operators in C. So for standard operators, we have the assignment, the equal one, so the one that we have covered in the first semester. So when we asks you, for example, to do a sum between two numbers and then to store it in the left part. So this arrow is equivalent to equal in C. It means that I will evaluate the expression, for example, a plus b, and the value of this expression I will put it in the variable name. So let's take an example of assignments with constant values. For example, here I will put the value, the constant 141 in the variable long, the value 3.14 in the variable pi, and the constant L in nations. However, while assigning, I can put the value of other variables, like in this examples, I can assign the value of x1a to the value of the variable called value, I can assign the value of male to the value of letter. Yes, and I can also assign the value of an expression to a variable, like again what we have done here. For example, in the first example, I'm multiplying pi by the power of r squared. So power, it calculates the power of two numbers. Yes, and I can have very complex calculations. So the value of the right part will be assigned to the variable on the left part. So let's I will focus on the last two examples. So here, bigger equal x greater than y. So x greater than y, x greater than y, and the answer of x greater than y will be either yes or no. So it will be 0 or 1. So I will put in bigger either 0 or 1. Here we are checking whether a, the constant character a is equal to the character a. So here we are using double equal, not just one equal as here. So one equal, it means assignation. It means we are assigning, we are moving a value from part to part. However, double equal, it's a test. It means it will check whether the two parts on the left part and the right part are equal. So here again, the answer would be either yes or no. It will be here 1, since a is equal to a, and we'll found 1 in the variable which is called correct. So what we have as a known operator, so the ones that you have used in mathematics, we have the plus, the minus, the multiplication, division, and the remainder or modulo. We have also the logical operators are the and logical, the or and the negation. We have the comparison operators, the equal, the different. So just pay attention of how we write the different. We have also the smaller, smaller or equal, greater and greater or equal. As for the logical operator, as I have said, so we don't have a Boolean operator, so we declare a variable as integer, and if the value true corresponds to the value 1 and the value 0 corresponds to the value of 4. For example, let's see here, we have 32 and 2.3, so 32 is different than 0 and 2.3 is different than 0, so the result is 1. 65.34 is different than 0, so here 64.34 is different than 0, so not 65.34, this is different than 0, so not different than 0, it means equal to 0, so it gives us a 0. Here we have 0 or something else, so it directly gives us a 0. So we have some particular operators in C. The first one is the assignment operator, and then the increment and decrement operators. So usually in C we use this stuff. However, in real life we don't we don't declare a variable and then add to the variable plus 2. We usually say let's add to the variable a 2. So if we have this kind of operations, we can transform it into like this. So if you can look here, if I have an expression which is equal to expression 1 or operation expression 2, I can remove this expression 1 and move the operation to the behind of the equal to have this 4. So we have this particular operators, the plus equal, the minus equal, the star equal, the division by, and the modulo. So let's take an example. So there is no example here. Let's take an example. Let's say I have int x equal 2, and then I will say x equal plus 3 minus 7. So what we have said, so pay attention to the brackets that we are using. So in fact, there's brackets here, and x will be equal to x plus 3 minus 7. So in x we have 2 plus 3 minus 7 equal to minus 4, minus 4 plus 2, so x will have the value of 2. Another example, let's repeat the same, but here let me erase. I have int x equal to 2, and then x multiple equal 3 minus 7. So here you are tempted to say that is equal x multiple 3 minus 7. This is wrong, because as I've told you, you should pay attention that theoretically there should be a bracket here, so it will be x equal x multiple 3 minus 7. So this is one type of a particular operator. We have the increment and decrement operator. Whenever I add 1 to a variable or minus 1, I can use the more compact operators, which are the plus plus and minus minus. So we have two types. We have either the incrementation, the decrementation, and we have the pre-incrementation and the post-decrementation. So this one we call it a post-incrementation. This is pre-incrementation, this one is post-decrementation, and this one is pre-decrementation. So post, it comes after, and pre, it comes before. So in order to understand what's the difference between all these, let's see the example here. So first, if for example you have just I++ on a sentence or I minus minus in a sentence, there is no difference if you use plus plus II or I++ if it's just one instructions. However, if it's inside or embedded in an instruction, it means that there are some other variables in the same instruction, so you need to pay attention. So if we say x equal I++, so I++ is a post incrementation. It means the incrementation will be done at a later stage. This one is equivalent to x equal to I, and then we will do I++. However, if I say x equal plus plus I, it means it's a pre-incrementation. First, I will do plus plus I, and then I will say x is equal to I. Sorry, x is equal to I. So you need to pay attention. What does it mean, a post or a pre? So for x equal I minus minus, so the minus minus here is a post decrementation. It means after. So first I will do the assignation x equal to I, and then I will do the I minus minus. So it's zoomed. Okay, I minus minus. So we'll have examples on these, so don't worry and just stick with us. So here an example, we have int x and n equal to 5. We have declared two variables, x and n, initialized with a constant integer equal to 5, and then we'll have x equal n plus plus. So as I have said, this is a post implementation. So first it means that I will assign the value of n to the value of x, and then I will do the plus plus. So at the end, x will have the value of n, which is equal to 5, and then n will have the value of 6. However, here, first I will increment the value of n, so n will be equal to 6, and then the value of n will be assigned to x, so x will be equal to 6. Let's continue. Let's move to the part which is called on expressions. So before moving, I will try to make another video since 59 minutes elapsed from here. So again, if you have any questions, do not hesitate to send it by me, and do not forget to hit the red subscribe button of the channel, and then hit the bell icon to turn on notifications. So till then, have a nice day and stay safe.